Hey Tube, welcome back. Today we continue our course in system design fundamentals. Today we will talk about the cap theorem. The cap theorem is a fundamental concept in distributed computing systems that helps to explain the trade-offs involved in designing distributed systems. Um, the theorem states that in a distributed system, it said that you can only achieve. Let's just look at the theorem. Basically, you can only achieve two out of these three following things. The consistency, we can only achieve two. So we can have the consistency and availability and the partition tolerance, or consistency and partition tolerance. So the consistency, that means all nodes in the system see the same data at the same time, regardless of which node they interacted with. In other words, if a write operation is successful on one node and a read operation is performed on another node, node, the read will return the result of the most recent write. We have the availability, and availability means that every request to the system receives a response without granulating that it contains the most recent version of the data. This means that the system is always operating and responsive to user requests, even if it returns slightly outdated information. So that means our application will be available all the time. And right now we have the partition tolerance, and the partition tolerance, the system can continue to operate even in the presence of network partition or communication failures between nodes. Network partitions can cause some nodes to become unreachable or isolated from the rest of the network. And since it's quite important to try to understand, because you find most of your choose it will be between a CB system, a CB system, or a AB system, let's call it, like availability and partition tolerance. Since let's say that we have a CA system, availability and the consistency, and we sacrifice the partition tolerance, but since that we have a distributed system, network failures is not something that we cannot avoid. We cannot afford to avoid partition tolerance. Because of that, a CE system, availability and the consistency system, it's not a real world system. So basically, you find most of the time you choose between a CP system, consistency and partition tolerance, or let's call it AB system, availability and the partition tolerance. And here, the CP system, it's a traditional relational database, for example, like MySQL, often polarize consistency and partition tolerance. When a network partitions occur, they may become particularly or entirely unavailable. AB system, it's like, for example, the NoSQL databases like Cassandra or a key value store. It prioritizes availability and partition tolerance. They aim to provide uninterrupted services, even it's the presence of network issues. The trade-offs, like many distributed systems, aim for balance between these factors, providing tunable consistency levels or tunable consistent availability system. Like systems like Amazon DynamoDB allow you to choose between strong consistency or eventually consistency based on your application needs. Let's talk about the real world scenarios. Like the cap theorem reflects the reality that network partitions are common in distributed system. Because of that, so systems often needs to handle such scenarios gracefully. The specific choice between C and A or B depends on the application requirements and tolerance for potential trade-offs. Basically, it's important to note that the cap theorem simplifies a complex landscape of trade-offs in distributed system. Some systems may offer various levels of consistency and availability, and the choice often involves announced understanding of the specific use case. So I'll just try to take an example to know which system. Let's say that we have a bank, and the bank, we want to make sure that all the data is consistent and all the nodes read the same data at the same time, because we cannot afford to have any problem with data losing. So we use a CP system. Let's say that we are in Facebook. So right now I'm in Facebook. I may see I want to see all the posts in the same time, but I have no problem to see the likes. So for example, I see 32 likes, and in fact they are 34. This doesn't hurt me that much, but it's important to keep see posts every time, and whenever I scroll. So that means I care about the availability more about the consistency. That doesn't mean that I will not have consistency. I will have a good consistency, or like, let's say, a tunable consistency, acceptable consistency, but it's not a guarantee in my system. So this is the way that we would try to talk about the consistency and the availability. And let's just and that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in future problems.